All right. In this explainer, we're going to break down what really makes for solid software architecture. And the best way to do that? We're going to follow a single API request through its entire lifecycle, right from the moment you click something on your screen to the second the data comes back.
So, here's how we're going to tackle this. First, we'll look at the journey of the request itself. Then, we'll dive into the architecture, the behind-the-scenes processing, the rules of communication, security, and finally, the principles that make for a clean design. Okay, let's get started with where it all begins, the request.
So, section one, the journey of a request. Everything kicks off with some kind of action, right? A user hits a submit button, an app pulls for new data, whatever it is, that one action fires off a very specific call to a server, basically telling it, hey, I need you to do something. And that something is a request. At its core, it's just a structured message, usually over HTTP. It's got headers, for all the metadata, a payload, which is where the actual data lives, and it's all aimed at a very specific address on the server, what we call an endpoint.
Right. So the endpoint, think of it like a specific door into a building. You don't just go to the main entrance for everything. There's a door for get user data, another for create new post. As soon as that request walks through the correct door, the system's internal machinery kicks in and takes over.
Okay, so the request is in the building. Now we get to the really interesting part, the core architecture. This is the heart of the logic, where we actually figure out what to do and get the work done. Now, this flow you see here, this is absolutely key to good architecture. It's all about separating concerns. The controller is like the receptionist, it just directs the request. Middleware is security at the door, doing initial checks. The service layer, that's where the real thinking happens, the business logic. And finally, the repository is the only part that's allowed to talk to the database. This clean separation is what lets you test things, maintain them, and scale them up without everything turning into a mess. So yeah, that service layer, it really is the brains of the whole operation. This is where your app's secret sauce lives. All the unique rules, like can this user actually afford this item? Is this username already taken? All that critical logic happens right here. It's the conductor of the orchestra. Okay, this is a super important distinction, entity versus DTO. An entity is how your application thinks about its data. It's the real deal, tied directly to your database with all its internal details, but you never, ever want to just send that out to the world. It's a security risk and couples your internal structure to your public API. So instead, you create a DTO, a data transfer object. Think of it as a custom-made box designed for one purpose and one purpose only, to carry specific data from point A to point B. It's got no logic, it's just a courier. So how do we get that DTO, that data box, back to the client? That's where serialization comes in. It's basically a translation process. It takes our internal data object and turns it into a universal format that anyone can understand, like a JSON string. That string then becomes the payload inside the response we send back, and boom, the request-response loop is complete. All right, section 3, processing behind the scenes. Now, you might think we're done, right? The client got a response, but not so fast. A lot of the time, the real heavy lifting hasn't even started yet. Some jobs are just too big for that quick back and forth. So what happens with those big jobs? Imagine uploading a huge video file or asking for a massive report. You can't just have the user staring at a spinning wheel for 10 minutes. That's a terrible experience. So what we do is send back a quick response like, yep, got it, we're working on it, and then hand off the actual task to someone else in the background. And that someone else is usually a team of specialists. You've got your parser, whose only job is to understand specific data formats like, oh, this is a CSV file. Then you have the loader, which is in charge of grabbing that data from wherever it is, maybe a settings file or another service. And finally, the worker. This is the one that actually does the hard work, like processing that image, totally separate from the user who made the original request. Okay, moving on to section 4, rules of communication. For all these different parts of the system to talk to each other without causing chaos, they have to agree on a set of rules. This is what separates a fragile API from a rock-solid, reliable one. And these are the big ones. The API contract, which is spelled out in a schema, is like a legal document for your code. It says exactly how things will behave. Idempotence is a lifesaver. It means you can send the same request 5 times, and it will have the same effect as sending it once. Think about that for a flaky internet connection. Stateless design is huge for scaling. It means any server can handle any request because no single server is holding onto a user's session. And pagination, well, that's just common sense.
You don't try to send a million records at once. You break it up into pages. Now for a really critical piece of the puzzle, security. Because honestly, none of this fancy architecture matters if it's not secure. And at the heart of it are two concepts that people mix up all the time, but they are completely different things. Let's clear this up once and for all. Authentication is about who you are. It's you showing your ID card at the entrance, maybe with something like a JWT token. Authorization is about what you're allowed to do once you're inside. Just because they let you in the building doesn't mean you have the keys to the CEO's office. First you prove who you are, then the system checks what you have permission to do. Okay, last section. Let's zoom all the way out to the big picture, principles for clean design. Because building something that works today is one thing. Building something that's still maintainable and scalable 2 years from now, that's a whole different ballgame. And this right here is the fundamental tug of war in software design. On one hand, you want low coupling. That means your components shouldn't be tangled up with each other. You should be able to change one without breaking 10 others. On the other hand, you want high cohesion. That means everything inside a single component should be strongly related and focused on doing one job really well. The real trick, the art of architecture, is finding that perfect balance between the two. So how do we actually manage that balancing act? Well, our number one tool is abstraction. It's the simple idea of hiding all the messy details behind a clean, simple interface. We define what something does, but we hide how it does it. Then, we use something called dependency injection to just plug in the implementation we need. This is the absolute key to wrestling complexity into submission. And that really brings us full circle. From that first request, hitting an endpoint, all the way through the layers of logic, the background jobs, and governed by these core principles. You can see that these aren't just a random collection of buzzwords. They're all parts of an interconnected toolkit. And learning how to use them together, well, that's how we go from just making things that work to building systems that are resilient, scalable, and built to last.